exponential decay. So the difference in there is just your k, your population decay is just negative because it's going down over time, right? So it's the same thing. Start with our initial population. So here, if we're talking about a half-life of radioactivity, takes it means it takes half the amount of atoms in a substance to disintegrate, whatever, basically get smaller. Radioactive substance, this thorium-230, no idea, is used to determine the age of caves, formation of coral, so that's interesting. Half-life of that is 75,381 years. So that means that if I start out with 2 grams, then after 75,381 years, I will have then 1 gram. So we want to solve out what is this K of the thorium, I don't know, thorium, whatever it is. All right, so here we're going to start out with our equation. A is our initial amount, so it doesn't really matter what our initial amount is. It could be 2 grams. And then E raised to K and times T. And we know after 75,381 years, there's always going to be half of that, right? So 1. So really there's no A that it gives you here, but it just says a half-life, meaning half the amount that you start with after that many years, right? And so we know our T. Sometimes it's confusing for students because it's just saying a half. Well, there's no A given to you. Well, you don't need an A because you know when you divide here, you will get a half because it's a half-life. Okay, so then I'm going to take ln of both sides, so ln of a half, or 0.5, will equal ln of E, but isn't that just 1? So can I just bring this exponent down and get K times 75,381 equals ln of 0.5, and then I can just divide by 75,381. So 75,381. So I do that, and I get, oh, this is a negative because it's decreasing, so I guess that should be a negative here, so then I should be dividing by a negative, and that's what's going to make this K equal a negative point. Lots of zeros. 1, 2, 3, 4, 5 zeros, because it takes a lot of time, right? 75,000 years. So that's our K. So then we can go ahead and write our equation. Y equals our A, which doesn't really matter, A E raised to negative 0.1234592 times T. So we can plug in any A now, any amount that we want to start with. So the next example says, okay, start with 2 grams. So let's plug in 2 for A, negative 0.00005 of them, 92 times T. And what's going to happen at 1,500 years? So we plug in 1,500 for our T. So T now is 1,500. 1,500. I put the comma in the wrong spot. Okay, and that's not a point. So 1,500. Okay, so now we just plug this into the calculator and we just see what we get. So we plug that in. We can simplify that if we want to. So negative 0.0138 e raised to times 2. So we could do that if we want to, or you can just plug that all into the calculator. So you don't even have to do this multiplication first. You can just plug it all into your calculator. So we can just do that, plug it in, and we get approximately, we should have about 1.97 grams. So that's how many grams we should have left after 1,500 years. Okay.